Okay, since the last video, what we did was I first changed the footprint a bit to matches more the robot better, as mentioned by David in the ROS topic. Then I started reading the source file for the DWA local planner, and I found something. First, I saw this debugging system that I can add trajectory rollout planner and I can show it the possible trajectories that are being calculated, which is very informative and very good for debugging parameters. And this you need to actually download the source and enable it, because I, at least, or maybe there's another other ways, but I didn't know how to do it. The only problem is it's not matching the robot movement, but it helps. So the first thing that I found that was very important for my robot was the actual forward point distance. In the forward point distance of the, in the, what do you call it, on the website, you don't get a lot of information about this, but this is very important based on a type of the robot, because this forward point distance is also used in the source code to align the robot to the path. So which means if you have a differential robot like this one and it's big, it's going to be very difficult to align the robot to the path. That's why I made the forward point 0, and suddenly everything became much better. However, still the robot was getting how do you call it, stuck sometimes, and it took it a while to figure out how to get out. And then I started playing around with the seam time and the Vx and V theta samples, which then you could see, for example, if I increase them, you could immediately see it in the where is the, you see these points. For example, if I reduce the Vx points, you see that it immediately gets well, it's not really getting that smaller, but it should. Let's play around. Yeah, you see the number of points reduces, the distances increases, and that sometimes helps and sometimes makes things actually much worse. And the other thing that was very important was the seam time. I said sometimes 1.7 is not really good, sometimes needs more time. And well, like you see, the more you let the sim period go, the trajectories will roll out more, and it can get out of deadlocks sometimes easier. One other very important thing that I found out was the cost estimation, the path, goal, and oscillation distance. I think the thing is, you cannot find one set of parameters that matches all sort of your robot movements all the time. You need to have at least like a couple of parameters for like closed corridors where you have a lot of obstacles, open corridors, and then switch between parameters using the dynamic reconfigure to find out what's best for the robot. But and finally, the other thing that I found out was that on the ROS forum on the DW local planner, there is a negative, penalizing a negative X. However, I don't see it, and where is it used in the source code? I'm not sure whether it's actually being used or not, or but I think the forward point distance, if you enable it, then the robot will move forward not as much as it should. Well, thank you very much for your help. I also hope that this video can be used for others for debugging your system, and you can just contact me for any questions that you have. Thank you.